Well, welcome back. We're now into Module 4, where we're going to be talking about program planning. And so let's go ahead and get into this material here. Let's first of all give a tour. There's basically two sections that we'll be covering here. And the first will be selecting the origin, the PRZ, the quadrants, and the axes. And so that's something that we're going to talk about. Then we'll break up into the second part, which is selecting the work holding methods and cut sequence. And so that's what we'll have for that. So please note, in this chapter, we'll have a new role to play. Now you are the programmer. And so this is, as I said, you folks being engineers, this is likely going to be the sweet spot of where you're going to be focusing your time, rather than the machine acting as a machinist on a regular basis. Given the speed and power of today's CNC machines, I'm sure you'll clearly see the value of planning the job before writing code. Make sure that your planning is easily understood by the machinist who will be using it as equal of importance. So we're talking about good communication, programmer to machinist. And so we saw what that document would look like. So you're having the code, you're having the documentation, all of that has to be clear. We plan and document safe, efficient cycle times, quick part turnaround, and operation sequences that create the least secondary process, preventing blurs and sharp edges, for example. Continuing on, a common error made by a misguided beginner is to write the command codes and then try to work out the details of how to make the programs work once it gets to the machine. For example, how best to hold the work so that the rapid moves don't wipe out the vise or chuck, or how to locate the work to verify the PRC, and so on. Very often, these are tricky to solve after the fact. To learn to plan away these problems, we add the following skills to your journey level kit. So that's the purpose of this module. So let's go in and talk about the first part of this module. We'll take a quick break and then we'll come back for the second part. So choosing how you will hold the work and the program reference zero location and axis orientation are intertwined decisions made at the same time and made first. They all must be chosen before any other planning is done. Only for book organization are these two vital decisions separated into learning units. So keep that in mind. So for the lathe PRZ, the lathe PRZ is always set at the work center line for X. The question is, where is the Z-axis reference? It must be based on two guidelines. What is the functional basis of the design, and can the location be set and verified? So for example, commonly the lathe PRZ is chosen at the outer tip of the work. And so that's what we're seeing here by the arrow, so center line X, outer face Z. So for functional based, sometimes the outer face isn't the functional basis for the object. There are 3 PRZ options for the job. So you can see there's multiple ways. You just have to be consistent in your code writing for doing this. So number 1, write the program from an existing PRZ, but clearly document that the setup person is to leave 2.050 access beyond PRZ for facing and turning the threads. Number 2, set the PRZ at the outer face and recompute the coordinates for the Z-axis. Be certain to document that on your setup sketch. And number 3, write the program from the existing PRZ, but use a coordinate shift in the program. You can want to be sure to document that on your setup sketch. So thus we see 3 different possible options. What about part reversal? If you look in the textbook for this module, for this chapter, you'll get some ideas of this. And so for the original text, that's figure 21.2 and 3. So it'd be figure 2 and 3 for this particular chapter, and the textbook that we've modified for this class. Since this job requires machining at both ends, would you plan for it for 1 or 2 setups? Does the internal thread holes make it impossible to set up as a bar job? And so these are the things that need to be thought about, the capability of the machine that you're using and stuff like that. Similar to the lathe selection, above all priorities, that the datum and functional basis of the part drawing determines the PRZ location. Next, choose a location that lends itself to reliable locations within the setup. Flat surfaces, corners, and holes are commonly used for verification. Choose PRZ features that lead to further datum priorities, especially when the part will undergo more than one setup change. All other PRZ selection suggestions beyond these are only convenience guidelines. So continuing on, mill job PRZ. That said, the lower left corner at the work's top surface is the most commonly chosen location. And so here we're seeing that shown here. So it's easily verifying choosing the PRZ in the lower left corner. LLC also places the work in the first quadrant. So for setup points and fixtures for odd-shaped work, or when there is no reliable PRZ or datum basis machined on the raw stock yet, we design fixtures to hold rough castings and forgings for production work. So for example, how would you set up to hold and verify PRZ on this rough casting before any machining has occurred? So that's something to be think about. The solution is setup solution. One solution is to build a setup into the fixture. And so the key point is the setup. So the set point isn't the PRZ, it is a known distance from it that must be documented in the planning. In terms of thinking about your career, in a small shop, a machinist might build the fixture, but that would take time away from part making it. In medium to large tool shops, the task is given to the tool and die maker, usually a senior member of the team with a highly skilled person. They also make stamping, extrusion, and forming dies, assembly jigs, plastic molds, and a lot of other challenging shop aids or production accessories like mill fixtures. Tool and die is a rewarding, well-paid career that begins by learning basic machining. So that's something to think about. Okay, I'm going to pause the video there, and then we'll finish up with the second module part.